Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi, and welcome to Geeks for Geeks. Today, we would be discussing yesterday's problem of the day, that is max level sum in a binary tree. So, without any further ado, let's get started. So, let me just open the board itself and see. Yep, let's move forward. Okay, sorry. Yep. Hi, Rishit. Okay, so I think we are good enough to move forward. So now here we are told that you are given a binary tree. Okay. So let us first understand what do you mean by a binary tree. So a binary tree is a tree which can have at most two childrens. At most two childrens. So here you are given that there is a particular level. So what do you mean by level? Level is the depth of the tree from the root. So if the given figure is like this, let's say it is a full binary tree. Okay, let's say it is a full binary tree or incomplete binary tree. Okay, so let's say that the level of this one would be 0, the level of this one would be 1, the level of all this is 2, and the level of all this is 3 itself. So these are the levels of the binary tree at each of this. These both have a level of 1, this has a level of 2. So let's go back. So you need to consider the sum at each level. Suppose the given value, what is the sum at each level? Suppose this value is x and this value is y, then the sum at level 1 is x plus y. If this value is a, this value is b, this value is c, this value is d, then the sum from this level would be contributed as a, b, c, d. Okay, and this value is e and this value is f, then the sum would be e plus f itself. Okay, so now here you are told that each point you need to find the sum and you need to return the largest out of them. Okay, so the sum of first level 0 is 4. The sum of negative 5 and 2 is negative 3. The sum of this one is 6. Negative, negative 2 and 6 is 4. 4 plus 3 is equals to 7. 7 minus 1 is equals to 6. That is why the maximum out of all this is 6. So that is why this is the output itself. This is how this output 6 is popping up. Let me see if there are any more test cases or not. Yes, there is one more test cases to cater. Now let us just see if this test case we can handle this or not. Okay, so now see. So now see that this is the level 0 and the sum of this is 1. This is the level 2, that is 2 plus 3, that is equals to 5. This is 5 plus 4, that is 9. 9 plus 8 equals to 17 itself. And this is 6 plus 6 plus 7 is equals to 13 itself. Out of all this, 17 is the largest, and that is why the output to this is 17 itself. Okay, now what we need to do, so we can clearly see that at each step we need to find the sum. So find sum in each level. So find the sum in each level and you need to return the maximum. Return the maximum itself. That's it, nothing else. Okay, so the only two hurdles in this problem is understanding the problem, which is the very first hurdle, and then the next one is implementation. So finding the sum at each level. That means we need to traverse the tree level wise. If we need to traverse the tree level wise, that means we need to do level order traversal, because there are three kind of traversal: pre-order, post-order, and level order. So we need to do level order traversal to complete this. Now, how would we do a level order traversal? So let me first show you a way to do that. That is by simply using a simple queue. Okay. So what I want is, I want this to be visited first, then this to be visited first, and then this is visited. So whatever I'm visiting, I would keep writing it here. So first, I would insert the root inside the queue. So what do you mean by queue data structure? Queue data structure is a simple data structure where elements come from the back and elements leave from the front. Just like in a real life queue, elements get added to the back and elements get popped out from the front. First come, first serve. Like suppose there is a person selling food, okay, like a street food, like street food stalls or something. So suppose I'm there standing, so if I came first into the street, that stall, I would be catered first. In the same manner, in the queue, the element which is coming first would be popped out first. Okay, fair enough. So now let us just move forward. So what we would do is, initially we would just insert one into the queue. After inserting one into the queue, after it has some elements, we would start this. Okay, so let us first write the code. Okay, like doing the level order traversal in a queue is done by the way known as BFS. But how that is working, let us first do that and let's talk about that only. First, let us code this and then we would do a dry run for this figure. First, let us code this. I think we are good to go. Sir, questions repeat kar do, sir. So the question tells us that we are given a binary tree. You need to find the sum at each level and you need to return the maximum out of all this. Okay, so I found out that each level I need to do a level order traversal. So I would be doing a level order traversal. So first I would be coding it and then I would be telling you. And just let me just mute this WhatsApp. Yep. Just let me stop the sharing part and let me mute this WhatsApp itself. Just a sec. Okay. I think we are good to go. So now let me just present the screen. Yep. Okay. Fair enough. So now we can just move forward. Okay. So first, what we would do is we would first insert it into the queue. So before inserting, that's a very basic, that if the tree does not exist, return 0. Okay, that is the most famous base case of a tree problem. Okay, so if the root, like there exists no tree, then the sum would be obviously 0. So if the root is equals to null, return 0. Okay, now the very next thing is that we would initialize the sum is equals to root dash date. So first I would code this up and then I would start the dry run. Why? Because before doing the dry run, how can I expect you, like most of you would be knowing pre-order like in order traversal. How this is working, that is might be a difficult issue for you. So I would be doing that part only. Okay, so queue data structure, we would be using a queue data structure and then we would be using node dash queue, and what we would do is we would push this inside the root, like push the, like if you just go out and BFS, so get a source, put the source inside the queue while the queue is not empty. while the queue is no queue dot empty. Okay, so I found this way as an easy way, but the idea of using the queue size might be confusing for beginners. Okay, so I would be showing you the way. Okay, so int count is equals to queue dot size itself. Okay, and now we would start the counting part. So int like tp is equals to 0. Int tp is equals to 0. Now we would start. So while count minus minus, or simply I minus minus, okay, or I minus minus. First we would store the value. Okay, so this is current sum. Let's say this is the current sum. So C sum. Okay, this is the current sum, and node star temporary is equal to q dot front, and then we would pop it from the q dot front, then q dot pop. So we would remove this from the queue, and then we would say sum plus equals to temp dash data itself. After all this, if there is after all this is done, if there is left something in the queue itself, okay, like if a left or right of that is present, so temp while this is present, and then if temp dash left is present, not equal to like is present, this if left is present, then q dot push temp dash left. If so, now we would just make it right. Temp dash right is equal to q dot push temp dot right. Okay, after all this is done, okay, we would say that C sum. Okay, after that we would say sum is equals to max of sum already and the current sum, and at the end we would return the result. Okay, so I think this is good to go. Let's just compile and see how many errors are we making. Okay, this one would be tp this one would be a simple tp dash right, return the value of the sum. Okay, okay, so now see, people who are acquainted with graphs might be good to go. Like people who are acquainted with graphs or people who are acquainted with queues are good to go till this part of the solution. But they don't get how this while loop is coming into picture. Okay, how this while loop is coming into picture, that they are not able to understand. Okay, so I would handle that itself. So let me first tell you a way to combat this. Okay, so this is the picture. This is the figure. This is this one. Not add to a new page, add to the previous page. Okay, so the very first thing you can do is that if this is confusing from your end, Okay, like you are not able to understand even a bit of this, like I minus minus. Okay, suppose you don't want to do this. If you don't want to do this, there is a way to combat this. The way to combat that would be, I would explain this code, but before, let me tell you the way to combat this. The way to combat this would be that you use an external data structure. What I would tell you this. Okay, so let's say that you have the same figure. Okay, so you have the same figure. Okay, so what you do is you make a queue of pairs. Let me just type it. Okay, so you make a queue of pair, queue of pair of what? Of the first one as node. Okay, let's write it. So queue of pair of node star comma the like integer, where you would first insert 4 with a level as 1. Then you visit the left of 4, and what you would do, the left of 4, that is 2, and the level would be the level of the parent plus 1, that would make it 1. Now the next one would be after left, this one would be right child. So right child, so let's do a level order only. Okay, so now 2 1. Okay, now we would go to the left of 2. Left of 2 is minus 1, and its level would be the level of the parent plus 1, that is 1 plus 1, that is 2. And after left is complete, we would do the root. Root is done, we would go to the right part. So right would is 3, and the level would be the level of the parent plus 1. This is how you can store the level. Okay, so the right child in the same manner would be 5, and the level would be 0 plus 1, that is 1. And this side would be negative 2, and the level would be 1 plus 1, that is 2. And this side would be 6, and 1 plus 1, that is 2. This is how you got the level at each step. So what you can do is you can have an array. Okay, you can have an array where we would hash according to the levels. Like what you can do is, this is index 0, this is index 1, this is index 2. So at index 0, you can hash the sum of level 0. At index 1, you can hash the level of sum 1. At index 2, you can hash the level of sum 2. You would submit this and this would pass. But suppose you are in an interview and the interviewer tells you that you are not allowed to use an auxiliary data structure. So in that scenario, you can't do this. So now comes the picture where you need to understand this. So if you are only preparing for problem solving, then this might, like, the other one can be the gateway for this. Or if you're just comparative programming, that one might be the gateway for this. Now let us understand how this code is working. So am I clear till this point? Just give me a quick one. Okay, there are absolutely very less people at this point of time. Only 4 or 5 people are it. Okay, so now see, let us see how this code is working. So first we are saying that sum is equal to 4, and then q has what? Q has the root, that is 4. Root is inserted. Now, till the queue is not empty, we would keep doing something. What is that something? First, we are finding the size of the queue. So I is equal to 1 because queue has only one element. Then we have the current sum, which is equal to 0 initially. Now we would go to the very first element. We would copy it in TP. So now TP is equal to the element 4. then we are removing it. So we would remove it. Okay. Now, what we would do is we would say current sum plus TP of data. So 0 plus 4 equals to 4. Now TP, now if 4's left exist, then it is 2. So we would push 2. If 2's right exist, we would insert the right of 2, 4. Now this is complete. Now again, we have something known as TP. We would assign 2 with TP, and now i's value is 2 because there are two elements. Now current sum is again 0. Okay, current sum is again 0. Okay, first we would have 2, then we would remove 2. Okay, first we would have 2, and then we would remove 2. So we would remove this 2. Okay, this is done. And then C sum plus equals to 2. So we would add it. Then 2's left exist. Yes, 2's left exist. That is minus 1. Okay, 2's right exist. Yes, it exists. That is 3. And the value of I at this point is remaining is 1. So I 1 is remaining. Now we can traverse one more element. That is this one. That is minus 5. Okay, so this one would get added, so this value would become 2, C plus TP of data, and this time again we would add negative 5. Okay, so this is doing what you know. I would be telling you this. Even at this point, if you're not able to understand, I would tell you this. So if you see the structure in the queue would first store 4. Then Q in the next part would store 2 and negative 5. Then Q in the next part would store 1, 3, negative 2 and 6. Okay. And rest all elements is getting added. So first we would only have this much. And then when we are removing 2, then after that we are inserting the left and right of 2 na, that is 1 and 3 is getting added after 2 is getting removed. So before 2 is getting removed, we have all the elements from a particular level. Before 2 is getting removed, we have all the elements of a particular element. Like एक level का पहला एलिमेंट जब क्यू में है तो सारे एलिमेंट सिर्फ उसी लेवल के ही एग्जिस्ट करते हैं. पहले क्यू 4 था, जब 5 रिमूव हो गया. ओके, लाइक लेट्स से this is 1, this is 2, this is 3, this is 4, this is 5, and this is suppose 6. So first we would have 1 in the queue, then 1 is removed, then we have 2, 3 in the queue, then suppose 2 is also removed, 3 is also removed, then we would only have 4 and 5. Now when 4 and 5 is also removed, the last one remaining is 6. So when we have only 1, then it is the first level. When we have 2, 3, then we don't have any other elements other than 2, 3. This is level 0, this is level 1, this is level 2, this is level 3. जब एक लेवल का पहला एलिमेंट क्यू में एग्जिस्ट करता है तो सिर्फ और सिर्फ उसी लेवल के एलिमेंट्स उस पॉइंट ऑफ टाइम पे रहते हैं. And that is why we are finding out the size of the queue. We are finding out the size of the queue. Like suppose we know that there are at this point there are two elements. So we would only traverse two elements. We don't care if there is 1, 3, negative 2 is kept. We don't care. Okay, that is why we are taking out the size and we are only iterating. Like see, if you just see, the value of I is not getting changed at this position. We are again changing, initializing the value of I when we come again here. Okay, so I hope this was the point at which you were not able to understand. I told you that thing, and I also told you a way to solve this issue. Like you can just use a queue of pair where you can just store the distances also and you can hash them in an array. So I think that was it from my side. So if you still have some errors left, you can quickly ask me. Okay, can we add some null values after the end of each level somehow so that we can eliminate the use of nested while loop? So basically, this looks a nested while loop, but this is not a nested while loop. Why? Because if you see properly, so nested while loop, so basically time complexity tells us, and the number of nested loop is the power to the power n. But not every time this is true. Why? Because if you see, each element is visited exactly once. So if we are visiting each element exactly once, that is the time complexity is big O of n. So the time complexity is big O of n. Even if we use nested loop or even if we eliminate the usage of nested loop, that doesn't make any sense. Now, if at each level you start adding some null values, then what problem would be that you are would be also iterating over null values. The number of conditional statements would increase. That would lead to a lot of unnecessary calls. I think so, but still it might be a scenario that you are thinking something different and I'm not able to get the solution that you are thinking. So it might be that scenario too. You might be correct, I might be wrong. Okay, so anything more from your side? If not I would turn this off the session in the next 30 seconds. So that was it from my side. If you're watching the stream in the recorded version, feel free to like and comment the video so that the reach of this video could be increased. That was it for today. Thank you and have a nice day. This is me, Siddharth, signing off. Thank you.